You are now tuned into the network. The the YouTube channel that takes complex networking topics and keep it funky when we talk about it. Today's topic is configuring OSPF on broadcast networks. Yesterday we did it on point-to-point networks. Y'all know what the difference is, right? A broadcast, you have several devices that you can speak to, whereas a point-to-point is just one point to one point. Really just two routers, really, or two devices. One device on one end, one on the other. We only need 2 routers for this lab. If you have the book, where's that page at? It's the book. If it's the first time you tuned into this channel, we typically lab from this book right here called 101 Labs, Cisco CCNA version 4. You can get a copy of this from 101labs.net. It's authored by Paul Browning and co-authored by Farai Tafa, who is a two-time CCIE. Experts agree that we retain only 10% of what we read and 90% of what we do. That's why I love this book, because it gives us something to follow, hands-on to after we read all this boring-ass theory when we read it, right? The official cert guide and all those other manuals and stuff like that. I was looking up some stuff on TFTP. I have a router that I bought on eBay. Yes, a router. Yes, an old hardware, 1841 model, and it's stuck in Raman mode. So I got to basically put the new image on it, and I'm trying to get it to work. So that's why I was looking up that this article right here. What the hell am I doing? GNS3. So yeah, we need 2 routers. Just drag and drop them like this right here, back to back, back to back. We got my man, plant-based brother, who's speaking Japanese over there in the chat room. I didn't know you spoke other languages there, bro. What's up, Johnny Nieves? Appreciate the retweet the other day, man. We are going to label and cable. What do we got? Serial cables today? Let me see. Y'all run me with that like button if y'all like what y'all see so far, even though we ain't talk about nothing yet. Let's see what we working with. Obviously we're working with OSPF. Configuring OSPF on broadcast networks. Yeah, so if y'all got the book, there's also a link in the description box below if you don't want to get it from 101labs.net. I don't know if their website is secure or not, but Amazon damn sure is. And again, that link is in the description box below. So it's page number 208, and it's lab number 48 of this book, right? If you have the book. If not, just follow along. Not only do we need a router, but we do need a switch in the middle. So I didn't see that. I did not see that. Y'all know I be trying to do these labs, live stream them, so I'm not this is not something I've rehearsed at the beginning or anything like that. So I'm kind of learning on the fly, and most of these topics I do know, because I do have my CCNA and stuff like that. But after you pass the exam, sometimes you just forget about all that shit, man. So we need a switch. Let's go ahead and drag and drop this bad boy right here in the middle. And we're going to go from 00 to 02 and then 03 to 00, right? So let me drag them bad boys up like this. We got Danny in the building. What's going on, Danny? Just read the task. Looks like he did a router 3 typo again. Really? He sure? Well, no. Let me see. Not in my book. In my book, he actually does have router 1 and router 2, and then switch 1 in the topology. You're talking about lab number 48, right, plant-based brother? I got my beard hair all over in the last lab in this book. Yes, lab number 48, page 208. He has router 1 and router 2, surprisingly. Last lab, he did have a typo. So we're going to FA00 to looks like FA02. But we got Gigabougie ports here. So we're going to go from 03 to 00 of that guy right there. And for y'all that are just following along, like I said, we're doing the easy and tedious parts right now. But as we get to the more complex and harder topics, I'm going to do the labeling and cabling offline before we start streaming. This guy's going to be switch 1. Y'all with me so far? Anybody got any questions or anything like that? So OSPF, I guess we could just talk about it for a little bit. It stands for Open Shortest Path First. It uses what's called the Dijkstra's algorithm. It's like some kind of, I don't know if he was like a German physicist or something like that. I can't remember who let me look him up real quick before I start just giving y'all random facts and stuff. Dijkstra, however you spell that, right? Dijkstra algorithm, and he, let me see, who was he? Edgar Dijkstra. Yeah, there you go, right there. So he was a Dutch computer scientist. So basically, he came up with these like mathematical computations or whatever, and routers and switches use the Dijkstra's algorithm to figure out the fastest way to get to your destination as far as networks go, right? So you could have a destination that's about, I don't know, 5, 6, 7, 8 routers away, right? But it uses this mathematical computation to figure out the fastest way to get there, right? And that's why they call it open shortest path first. And what else can we say about it? It is an open standard, so that means you can use it on not just Cisco routers, because I know y'all know I primarily focus on Cisco devices and Cisco certifications and stuff like that. But you could also use it on, like, say, Juniper routers or Arista or Extreme or whatever, you know. So that's why they call it an open standard, because you can use it on other devices. But like I said, this I typically do this. I started this channel when I was studying for the CCNP exam, right? And I was just documenting my journey, and it just started becoming to a point where, you know, I realized, oh snap, people are actually watching me. So I started doing more tutorials and just started going back to the basics and stuff like that to bring people along. And you know, I just love teaching this stuff. Plus, they always say the more you, if you're able to teach something at a specific level, then you really, you know, you start to learn it at a deeper level. So let's get some labeling here. This network right here is the 192. Let me move this bad boy right here. Y'all got any questions so far or anything like that? Anything y'all else? Any other fun facts y'all want to know about OSPF? I try to spit as many as I know off the top of my head. This network right here is the 192. You got the Fat Finger Squad in the building. Gonna watch me make some mistakes while I'm typing over here. 20.1. Y'all know that why we call this the Fat Finger Squad, right? Because I had some what the heck is going on with this mouse? I had some live streams that we tried to do, and for some reason the device wouldn't. I couldn't remember. It couldn't ping across, and I realized, oh shit, I made a typo. And somebody chimed in and was like, Fat Finger Squad, and I was like, okay, you know what? That's what we're gonna call each other, Fat Finger Squad. Every time I make a mistake, we just talk about how we fat fingered what we made here. So that's gonna be that network, the 20.2 network. No. Yeah, that's the 20.2 now. No, you know what? That's not the network. So this is the IP address for that interface, and that's going to be the IP of that address of that interface. So this whole thing is going to be the 20.0 network, if that makes any sense, right? Remember what we said in the last stream, right? Typically, when you are designing an OSPF network, you start off with the backbone area, which is called area 0, which is called the backbone area. It's kind of like the center of your network, right? So these two guys right here, we're going to make them OSPF neighbors, right? And then they're going to be sitting in this one area, right? Which is the center of the network, is the backbone area, area 0. If we had another set of routers and maybe another area right over here, maybe we can call that area 10 or area 51, right? And then that will be another, like, kind of like a broadcast domain for the OSPF network, right? For another OSPF area, right? But typically you start off with area 0, the backbone area. Let's see here. Google, let's see right here. Just read the task. Looks like, yeah, so Dutch. Oh, yeah, so he has Dutch. Rotterdam, represent. Google Maps uses it. Oh, see, I didn't know that. Google Maps uses the Dijkstra's algorithm. That's very interesting to know. Really? I might have to look that up. See, it's little shit like that. I never even knew that. But, and y'all know I always compare networking to roads and highways, right? And I said that OSPF is a type of dynamic routing protocol, right? So when we might have one way to get to a specific network destination, right? But if maybe a link goes down or there's too much traffic over there, the OSPF will dynamically learn another way to get there, and it's the shortest way that it knows, just like what a GPS does. And that's probably why the Google Maps uses it, because it uses the same algorithm. I didn't know that. I might need to fact check you there, Johnny. Not that I don't believe you, but yeah, I did not know that, if that's true. So let's go ahead and power these bad boys on. I think I'm pretty much done with the labeling and cabling, right? He switch 1. I I guess if y'all want, just to make it a little easier, we'll show that these guys are in that area. Right? Anybody got any questions or anything like that? Anybody lost? I know I might be losing some of y'all, but you know, this is a safe space. If y'all have any questions, let me know, because it's gonna get harder than this once we get to the other book. The other book is the CCNP book. Let's go ahead and use orange today. Apply, bring that back, bring that ass back, and then just to show y'all, just to remind y'all that this is area 0, which is the backbone area, right? Now, if we want it again, like, just so y'all see, if we had an area right here and we had like maybe 3 routers right here and we call this area 10, that's just another area, right? But typically you start off with the backbone area. And this is kind of like the broadcast domain for the OSPF, kind of like the OSPF area pretty much. And all the routers in this area are going to be, you know, flooding these what's called LSAs and LSUs. They're basically like it's kind of like maps, not really maps, like directions to other routers in the network. And then everybody kind of like shares those routes with each other, not with each other. They share it with what's called the designated router. He's the one that carries like all of the main map, which is called the, what is that called? Pretty much the OSPF database, but there's another name for it. And it has all the ways to get to everywhere in the network, in the OSPF area rather. But let me go ahead and delete that bad boy. Let's power these bad boys on and console into each one of them. 1, 2, 3. So router 1, switch 1, and close that. Close that. This is my actual router that I have here, and he keeps coming back up. So let me move him over. Rotterdam is great. Love Amsterdam. Oh, that's what's up, man. I ain't never been, you know, I never been to Europe at all, man. Typical American, right? I mean, I've been to like South America and Mexico and stuff like that, Canada, but I have yet to be in Eurasia, Europe or Asia. So, Johnny, I'll just mess with you, man. I mean, if it's true, I'm gonna go ahead and go with your word for it, man. But don't be coming up in here spitting some random facts, some false facts in here, fake news, you know. So, but that is interesting to know if Google Maps does actually use the Dijkstra's algorithm. I never knew that, and coincidentally, I compare networking to roads and highways, and yeah, that's really interesting to know that it uses the Dijkstra's algorithm. So, in case y'all don't know who he is, that's the guy pretty much that came up with the mathematical computations for the Dijkstra's algorithm, which is basically the root of OSPF, right? So, so he was also a software engineer, a system scientist, a science essayist. What is he, part Jamaican? All these goddamn jobs. What else he did? Computing science. So he was a mathematician, worked as a programmer. Jesus Christ. But yeah, he's a smart dude, and he's still around too. No, he died 2002. My bad. I'm sorry. God bless the dead. But yeah. So thank God for this dude right here. If it wasn't for him, I guess Google Maps wouldn't be around and OSPF wouldn't be around. But you know, it's smart people like him that help move the future and move the world forward, right? So while these bad boys are still booting up, I'm gonna continue talking shit and try to console into the other two. What else y'all want to know about OSPF, man? So today, let's go ahead and read the objective. It's for us to learn and understand how to enable OSPF on broadcast network types. It's pretty much the same way like we did yesterday. Yesterday, remember, we did in a point-to-point network, which was basically routers, like they were back-to-back. These routers ain't back-to-back, right? They kind of back-to-back, but there's a switch in the middle between them two, right? These two right here. When they were back-to-back, like it was router next to the router, and they were plugged up to each other like that, that's considered a point-to-point network. But now we put in a switch between them two, right? That's where he was. He was 20.1 and he was 20.2. What am I doing? See, that I fucked up the whole topology here. He's 20.1. He's 20.2. But this will be considered, and it we'll go ahead and verify. We'll run some show commands to show you that this is the broadcast domain, right? Or OSPF broadcast network. So we're going to enable OSPF on broadcast network types. These include Ethernet and token ring, although you are not likely to encounter token ring. Token ring is an old, super old network type. Nowadays, you're going to run into Ethernet, which is pretty much the standard when it comes to the internet and local area networks, right? So close that bad boy. If you guys want to know, yeah, he is a genius, man. He is a genius. If he did all of that, man. But God bless that dude. So y'all want to join the Discord server? If y'all want to talk to me offline, or if I make any changes to the schedule, typically I stream Monday through Thursday, 8 p.m. Eastern Standard Time. So router 1 is still booting up. He's still waking up like, man, it's 8 o'clock right now. I'm trying to take a nap. I'm still trying to console in the router 2. This is the other reason why I want to get my, I have Boston Netson running in the background there. I'm still in talks with them, trying to get a promotion to copy from them. Okay, so router 1 finally decided to wake up. Lab purpose: enable OSPF on broadcast network types is a fundamental skill. OSPF is the most popular interior gateway protocol. If y'all know what that is, right? So normally we want to use OSPF on, I want to say the local area network. Now I want to say that. You want to use it on an interior network. So in other words, your enterprise network that is like your network on the inside, not on the wide area network or the exterior gateway. There's only pretty much one exterior gateway protocol, and that's BGP. That's the one that's primarily used on the internet. OSPF, EIGRP, RIP, those are considered interior gateway protocols because we use those on the interior, like on your enterprise network. I don't want to say local area network because you can have kind of like a wide area network within your network, but it's just not on the internet, if that makes any sense. So what else we want to say about that? It is imperative for us to understand how adjacencies are established on broadcast network types. OSPF uses the concept of areas, which I've explained to y'all. In order for two OSPF-enabled routers to establish adjacency, they must reside in the same area. Unlike EIGRP, which uses ASNs. BGP also uses ASNs. ASNs are autonomous system networks. So instead of using areas, they use what's called ASNs, autonomous systems. So this would be like ASN 1. And you can have another one over here with a bunch of routers within it, and that'd be like ASN 10 or whatever. BGP and EIGRP does that. OSPF, which was areas. I don't know how many times I'm going to tell you that, right? But I'll repeat it if you need to. If you need to ask me in the chat room, don't be afraid to ask. You know, there's no such thing as a dumb question. This is a safe space, right? Unlike, so OSPF is enabled using a locally significant process ID, which I'll show y'all just like we did yesterday. So it's really similar. It's just the topology is slightly different from yesterday's stream, right? So let's go ahead and configure the host names. Task 1, we only got 3 tasks today, right? Task 1 was to configure the host names on router 1, router 2, and switch 1, which they've probably already labeled, right? He is router 1. Whenever he decides to wake up, we can see he's just switched, right? We just turned him out took him out the box, and by default that's his name, right? So we're gonna go to enable mode and then global config mode, and then we'll change his host name to SW1 for switch 1. Right, notice the prompt changed to switch 1, and then we'll go to router 2 and do the same thing. I thought I clicked him to get in there. Let's go ahead and console like this, boom. While he decides to wake up, let's move on to task 2, and then task 3 we'll wrap it up, right? So task 2 says to configure VLAN 4010 on switch 1. I hope we can do that. VLAN 4010 on switch 1, and name it OSPF VLAN. Assign ports FA02, which I have gigabit ports, so I'm going to use gig02. If you're using Packet Tracer or even G or any other simulator, make sure you're paying attention to your interfaces there. Yours might be different from mine. I've got gigabit ports here, so mine is going to be GI02. Assign ports, in my case, GI02 and GI03, that one right there, to this VLAN as access ports. So we're going to put those 2 ports in the VLAN 4010, and we're going to name it OSPF_VLAN. So we'll go to switch. Well, let's see. Router 2 decided to wake up finally. Anybody have any questions or anything? Sounds like an airport in there. You know why? You know why, Pete? Because I got my damn routers on. Let me turn this thing off. That better? I do have hardware, actual hardware, man. And not only that, this router, my laptop is pretty loud because the GNS3 is running loud. Let me close all this other stuff and make sure it's not using up. My bad about that, Pete. He sound like a damn airport in there, man. What the fuck? Let's turn on. Okay, so he's already router 2. We don't need to change his host name, so we're good to go. Go to switch 1. Right, we'll configure the VLAN. That's easy. We're easy enough. We've done that for maybe the past 5-6 videos, right? Take that back. Maybe before that, when we were doing local area network stuff. So he's VLAN 4010. And then we're gonna name it with just the name and just say OSPF, all caps, right? OSPF underscore VLAN. Y'all with me so far? Anybody any questions? And then we'll verify our work. Don't matter how small the task is, we verify our work, right? 4010 OSPF VLAN. Then they said they wanted us to put that port and this port in that VLAN, right? So we're gonna go back to global config mode, interface GI02/2. I'm just talking shit, mate. You don't have to turn on everything there. It's all good, man. Y'all mess with me, I mess with y'all too. So switch port mode access, right? We're gonna make it, we're hard coded as an access port, right? As opposed to a trunk port, which carries all the VLANs. This is just gonna have one VLAN, right? So we're gonna say switch port access VLAN. He said 4010, right? 4010. Don't make me fat finger squad that. Interface GI0/3, and we say switch port mode access. The hard coded as an access port, access VLAN 4010. We verify our work with show VLAN brief, and we'll see that we put those two ports, right? Gig 02 and Gig 03 in VLAN 4010, which is named the OSPF VLAN. So was that it for task 2? Nope. They also wanted us to configure the IP addresses on router 1, which is this guy right here, and router 2, which is this guy right here, and enable them. So configure the IP addresses and enable them, right? So we're gonna go to router 1 first, and we'll go to interface FA00 and put that IP address on it, and then turn it up, right? Or turn it on, right? So we're gonna go to config mode, interface FA00. His IP address was 192.168.20.1. The subnet mask is /20, which is 255.255.255.252, right? We do no shut to turn it on, right? Because we know that routers, by default, the interface are down out the box, right? And we do show interface, show IP interface brief. Actually, let's do this. Just show IP interface GFA00 so that way we can see everything, right? We go here and we verify that that is correct. 20.1, right? That was 20.1? Yes, it is. /30. And he's up. Good to go. So we're going to go to router 2 and do the same thing, but we're going to put that IP address on that interface, right? Y'all with me so far? So we'll go to global config mode. Interface. Don't worry, Pete. I'll get you back, man. Interface FA00. Switch port. My bad. What am I doing? IP address. What am I doing? IP address. I had a brain fart there. 192.168. I'm trying to think of a prank to get Pete back with. 168.20.2, and his subnet mask is 255.255.252, right? Right, because this is the CIDR notation of the subnet mask, right? /30, and then this is how we write that subnet mask: 255.255.252, right? So if y'all know anything about subnetting or how to do it, there's an app called Practice Subnetting. That's how I kind of learned. You know, it throws random IP addresses and it asks you what the first host is, what the last host is, what the broadcast is, what's the subnet mask, all that stuff. And then that's how you kind of practice it, right? There's also another website, I think it's like subnetting.net. There's a whole bunch of them. Once I find them, I'll put them in the chat room over there. But you got to get your mental subnetting and try to learn them to do them quick. No shut to bring it up. Show IP interface FA00 to verify that. And we'll see that is configured correctly. And the broadcast address is that, right? We didn't do that. That's just automatic. That's just a known broadcast address, right? So that was task 2, task 3, and then we pretty much wrapped it up. If I don't just talk, if I just stop talking so damn much, we could probably wrap these up in like a half hour, man. But then I'll wait for a little bit to for some people to you know log in late, or they come into the stream a little late, and not only that, I'll give a little lecture on some of this stuff before we start labbing. Task 3, enable OSPF in area 0 between router 1 and router 2, right? So I know I labeled it that they're in area 0, but now we actually got to do it. We actually got to put them 2 routers in area 0. So we got to go to router 1 and do that, and we got to go to router 2 and do that. This part right here just was just to kind of, you know, how do I say, demonstrate or display that they're in area 0. We actually got to go in there and configure that, right? Use process ID 1 for router 1 and process ID 2 for router 2. And they did that, put them in 2 different process IDs, just to show you that those numbers, those process IDs are locally significant. The process IDs ain't got to match. That's EIGRP. Like, if you have a router, if you have 2 routers in like ASN 110 for EIGRP, this router got to be an ASN 110, and that router, it's got to be an ASN 110 for them to be neighbors. You ain't got to do that with OSPF, and I'll show y'all real quick, right? That's what they're trying to do. That's why they put them in different process IDs. So we go to global config mode, and we say router. That's the key word to go into that configuration mode. I put the question mark for context sensitive help, and you'll see we can enable BGP, we can enable EIGRP, we can enable OSPF, we can enable RIP. Well, guess what? We're going to enable OSPF because that's what we came to do today, right? Question mark again, and it'll ask you what's the process ID. They say process ID 1 for this case, right? Once you do that, you're going to be in router configuration mode, and from here, we need to say what networks, what interfaces are going to participate in OSPF, and what process ID. In this case, it's going to be process ID 1, right? We only have one interface here, right? And that interface is in this network right here, 192.168.20.0 network, the O network. .1 is the IP address for that interface right there, but it falls in the network 20.0, right? So when we say this network statement, we're saying whoever falls, whatever interface you have on this router that falls in this network, put them in OSPF process ID 1, area 0. And that's what we're going to do here, right? So we say network, and then 192.168.20.0, right? Because that's the network address. Remember, this is part of subnetting. You just got to learn how to do that. And then we're not putting the subnet mask here, right? The subnet mask would have been 255.255.255.252, but we're not doing that. We work with wildcard masks when it comes with the network statements. We went over this yesterday, but I'll do it again, right? So the wildcard mask, the way you come up with that is you type in 255 minus whatever you're trying to do. So in this case, the subnet mask was 255.252, right? So the first subnet, I'll show y'all real quick, right? Let's go back to that subnet mask, the original subnet mask, right? Which is this guy. That's not, it's flash 30, but I want to show y'all the actual subnet mask. Is this guy right here, right? You say, this is how you do it. 255 minus whatever subnet, whatever's on the subnet mask, right? So you, in this case, it'll be 255 minus 255, which is what? You ain't really got to be that smart to do this part right here, right? So 255 minus 255 is what? Is 0, right? So the wildcard mask, the first octet will be 0, right? When we go with the next one, same thing. 255 minus, in this case, 255, which is right there. That second octet, right? This guy right here. So 255, y'all know what this is, right? Anybody? That's y'all pop quiz for today. What's 255 minus 255? We already know that. It's 0, right? So we do 0 for the next octet, right? So 0. Same thing with the third one. I ain't gonna do that again, right? Now this part is a tricky one, right? That last octet was 255, right? So we just say 255 minus 252 in this case is 3. So that is the wildcard mask that we're gonna be working with. 3. So this, we're saying whatever interface we have that falls in this network, right, with the subnet mask, well, in this case, wildcard mask, 0.0.0.3, but the subnet mask is actually /30 or 255.255.255.252, right? Whoever falls in that interface, have them participate in area 0. That's what we're saying with this, right? Let me make sure, because I ain't gonna front for y'all. Let me click the question mark before I lead y'all astray here. So area, right? And then after that, it's gonna ask you what area you want them to participate in. 0 in this case. I ain't never seen this right here. Oh, you can put it as the area ID and IP address for. I ain't never knew that right there. But we're doing it in we're doing it in decimal value. So we're just area 0. So this, we only have one interface, and it's in that network 20.0. So that will put him in that area, right? And before I do that, let me do this. Before we even do this part right here, I want to show y'all something real quick, right? We do show IP protocols. This is a whatchamacallit, a verification command, right? Y'all any questions so far? Am I losing anybody? Remember, there's no such thing as a dumb question. We got my man Dave W checking in, Fat Finger Squad. So we do show IP protocols. Let's see what we're running so far, right? Before I even, that's the network statement. Just remember that part right there. I'm gonna copy it and we'll paste it later. Show IP protocols, right? We see we already enabled OSPF 1, right? This is our router ID. How's that determined? The router ID is determined by the highest loopback address on the router. Well, guess what? There's no loopbacks on here. So, okay, well, we don't have any loopbacks. What's the next highest physical interface? Their IP address. In this case, it was 192.168.20.1. I'm sorry, he's 20.2. Shit, what am I doing here? Hold on, y'all. 20. Oh, I'm in router 2. That's why. My bad. Fat Finger Squad. Okay, that's why. That's why. All right, so I meant router 1. I'm glad I didn't do that yet. This part right here was supposed to be 20.0, but on that side. It's going to be the same network statement, but either way. So I already configured, basically I already configured OSPF on that side. I need to do it on this side. So we're doing the same exact thing, right? Go to global config mode, router, in case anybody missed it, or if anybody just walked in late. Router OSPF, same thing here, right? This was supposed to be actually 1, and the other guy was supposed to be 2. So I need to fix that. It's a good thing I made this mistake. So router OSPF 1, right? And we put our network statement. Before we do that, show IP protocols. Yeah, that's router 2. Yes, you're right. So, IP protocols, right? OSPF 1. His ID, I'm glad I checked that out first too. See, this is why we have to verify with our show commands. So his router ID was 20.1. And that's the reason why I was able to catch that mistake, because I ran that show command. So that's why his router ID is supposed to be that. His router ID is actually supposed to be 20.2. So we'll fix that in a little bit, right? So let me make sure I put the correct IP address. Yeah, 20.1, right? So, and that's his router ID. So we go to global config mode, and we set router OSPF 1. We'll put that same network statement, right? It's the same thing on this side, right? It's going to be the same thing, because they both fall in that same network, 20.0 network. He falls in the 20.0 network. He falls in the 20.0 network. He just happens to be 20.1, and he just happens to be 20.2. So they fall in the same network, right? So we press enter there. Jesus, I forgot the network keyword there. So network. Y'all with me so far? So yes, Pete got that correct. He caught that mistake too. So now that we put that that statement, so now we just do show IP protocols. That's one command that y'all want to make sure y'all know too. So his router ID. Now his router ID is 20.1. We're gonna have to go in here and fix this. So it's a good thing. That's some little things that we can do to fix this, right? The process ID was 1. What else we got here? So his router ID is 20.1, right? And we said the way the router ID is determined is by the highest loopback address. Well, I don't have any loopback address. Well, what's the next physical IP address that's on here? The highest IP address. There's only one in here, and it was 20.1, and that's how he was able to get the router ID. What else we want to do here? Maximum path is 4. I forgot what that is. This, I don't want to get a little too deep into this. There's like stub networks. There's NSSA, which is not so stubby areas. It's like OSPF can be really deep subs. You can write a whole book on OSPF. I'm not going to do all of this right now. It's supposed to be introductory stuff, right? So we know that the administrative distance for OSPF is 110. I like to call administrative distance as pretty much like the distance of somewhere, or like the mileage to somewhere, a specific destination, right? Or actually, the more believable the route is. So the administrative distance is a number between 0 to 255. The higher it is, the less believable the route is. So the lower the number is, the believable the route is. The lowest one will be a connected route. So a connected route is physically connected to us with a cable. We know that we're close to it. We're physically connected to it, so we believe that route for sure. Is the static the administrative distance for that is 1, not static route, connected route. I'll show y'all a list. Real quick. I know I'm kind of straying off here, and we're going past 8:30. So let's do this, and then we'll go back and fix the other side, right? Administrative distance chart. I pulled this up before, as you can see. Boom. Boom. Real quick. Y'all know I love this shit, and I like talking about this stuff. So where's he at? Right here. That's the list of administrative distance. Anything that's connected is 0. So that's the most believable route. And then after that, static routes. We manually configured it with a static route. We went over static routes about 2 videos back, right? 3 videos back, and then 5 for EIGRP enhanced IGRP summary route. A BGP route external is 20. What we came to do today, OSPF. The administrative distance is 110. How's that determined? Right here. We'll even run the look at the routing table, and I'll show y'all that too. But the default for administrative distance, you can change the administrative distance and be like, hey, this is a more believable route. But by default, it's 110 OSPF, right? Hold on. Let's see. If y'all like what y'all see so far, man, hit me with that like button and make sure y'all subscribe, man. I'm gonna try to do a giveaway once we get to a certain amount of subscribers and stuff. You know, y'all let me know what y'all want to see, or what y'all want me to give away, man. I'm not giving away my hardware, but I'll give away a book. I'll give away any kind of like Udemy courses or anything like that. Whatever y'all, give me some ideas of some stuff that I want to give away to anybody, to my subscribers and stuff, man. So what do we needed to do? We did the network statement for this router. We could also do show IP OSPF neighbor, and we'll see we don't even have a neighbor. Well, I thought we configured it on here yet. No, we didn't. We'll do that right now. Well, we was halfway fixed. We was halfway doing it until I fat fingered it. and found that mistake, right? So we need to erase that part, right? So right here we said we made it OSPF 1. We needed to put this guy OSPF 2 in the process ID is area 2. I mean the process ID is 2, and it really don't matter. We can make it both the same because remember it's a locally significant ID, the process ID, right? So we can leave that as is, but I'm just following the book to a T. They said they wanted router 2 to be OSPF, the process ID to be 2 on this side, right? So let's go ahead and global config mode. What we did here, yeah, that's correct. That's the correct router ID. So he is 20.2, whereas the other guy was 20.1, right? Right, router 1, he's 20.1, and he's 20.2, router 2. Right, so that was correct. What we needed to fix was this. Really don't matter. Like I said, we'll do a show run to see what we had so far and then get rid of that. And the way you delete things, kind of like, how do I say delete things? To remove statements in your running configuration is the no command, right? So just no is the keyword and then you remove it, right? So in this case, what we had this right here. That's what we made, right? Router OSPF 1. He needed to be OSPF 2, right? Y'all with me so far? So let's go in there and then do no that to remove it. So we go to global config mode. Oops. And we say no OSPF 1, right? And then we do a show protocol, show IP protocols. We're not running any routing protocol. See that? Now it's gone. Remember we did it earlier. We did show IP protocols and it gave me all this other stuff, right? So now we're going to go back to global config mode. We're going to say the correct process ID was OSPF. It was 2, right? But remember, I could put 99 here if I only wanted 999 if I wanted to. It don't matter because this is a locally significant number. He could have whatever process ID he wants. What got to match is they need to be in the same network. So the network statement, they need to fall into the same network in this case. So we'll do 2 because that's what Paul Browning wanted us to do. And if in case you guys are late or just checking in, make sure you get you a copy of this book if you want to follow along. Get a copy of it from 101labs.net, or there's a link in the description box below. And you can get it from Amazon. I think it's like $40 for this book, whatever. So what they wanted us to do? The network statement. So we did the same network statement. Y'all remember this part right here, right? So 192.168.20.0, right? And then the wildcard mask was kind of like, it's like a reverse of a subnet mask. So the subnet mask is like the 255, all that stuff. And then the subnet, the wildcard mask is kind of like the reverse. That's why we did the math over there with the calculator. So in this case, it was 0.0.0.3, which equates to 255.255.255.252, right? And what area we said? Y'all remember? Area 0. That's correct. The backbone area, right? And then after that, we press question mark for context sensitive help. And you see the CR, which means carriage return. That means there ain't nothing else you can type here. So go ahead and press enter, right? Because I know everybody's suspenseful over here, waiting on the suspense. Like, man, go ahead and configure OSPF. God damn it, you talk too much. So now that we get out of that, we do show IP OSPF, and we should theoretically have a neighbor here. Let's do show IP protocols. Let's do this. Let's just wait for a little bit and see if a neighbor comes up, because we're in the same VLAN, right? Because we're in the same VLAN, right? And typically when we're looking for neighbors, we say hello every 10 seconds until we find somebody that's in our network. Unless I'm missing something here. You know what I'm missing? I think I didn't turn up this interface. Did I turn up this interface? Let's see. He should have been a neighbor by now. Anybody got any questions or anything so far? Or, you know, there's no such thing as a dumb question. You know, just ask away, man. We got some smart people in here. We got Pete, who already pointed out my mistake. Like, yo, man, that's router 2. What you doing? Yeah, I found that already. But yes, I did find that mistake. He should have been a neighbor by now. Let's see what we missing here. Let's see. Let me finish the rest of this. Enable OSPF in router between router 1 and router 2. Use process ID 1 for router 1 and process ID 2 for router 2. And also to verify the network type for the Ethernet link between router 1 and router 2. I think, do you use OSPF at work? No, I do not. I use EIGRP at work because we have primarily a Cisco environment, and Cisco's proprietary routing protocol is EIGRP. So, no, I work with EIGRP, not OSPF. I'm missing something here, and I believe the interface is probably not even turned up. Let's verify. We need to do a little bit of troubleshooting before we move on. So IP interface brief. He is up. 192.168.20.2. Did I put the right network statement? 192.168.20.0. Area 0, that's correct. I think he said yesterday they used, yes, correct. So router 1, this is his interface turned up. Show IP interface brief. 20.1, and the other guy was 20.2, right? Yep, 20.2. He's up as well. Let's see here. These switches be kind of like funky too. Let's see if we put them in the correct VLAN, because we looks like we have to do some troubleshooting today. Some bonus for y'all. 02 and 03 are both in the same VLAN, the OSPF VLAN. Let's see here. Let's do show IP OSPF neighbor. We don't have a neighbor yet, so we definitely verify that you're. I think we need to put. Let's do this. We need to see the broadcast type. So in this case, show IP OSPF interface FA00. We need to be in the broadcast. We need a broadcast type, and that's the network. That's what they wanted us to verify. And the network type is broadcast. So that's correct. Yeah, I remember that's another show command you'll want to look at too. This gives us a wealth of information. We see that the interface is up. The internet address is that area 0. Process ID was 2. We said hello. We say hello every 10 seconds. We consider the neighbor dead 4 times the hello, which in this case is 40. Right? We say hello every 10 seconds to our OSPF neighbor. Right? Every 10 seconds. The 4 times the hello will be 40. After the 40th second, we consider the neighbor dead and we tear down that OSPF relationship or adjacency, right? We don't even have a relationship here or an adjacency, so we definitely got to do some troubleshooting here. Let's do this. We are missing something here for sure. OSPF neighbor, show IP protocols. Let's see here. 192.168.20.0. 0003, area 0, that's correct. That is the router ID. OSPF1, the other one was OSPF2, right? The other thing I needed to do too is let's verify. Let's look at our running command. Yeah, so process ID is 2 on this side. And remember, it doesn't matter. It don't even make a difference. So, because they're locally significant, the process ID. Let's do a show run real quick. Let's do a show run. And this is kind of like a last resort too when you do that, because now you're looking at everything, see if what's turned up or what's not on or whatever. Do we even have routing enabled? Well, I'm sure routing is enabled. So show IP routes. We're directly connected to the 20.0 network. You don't need to have any static routes or anything like that. Router 2 FA00, and then router 2. Let's see. Can you ping across? Oh, finally, Paul then chimed in. And how about router 1 and router 2 FA00 VLANs? Router 1 and router 2's FA00 VLANs. Like you're saying for them to participate in 4010 VLAN? Like, probably encapsulation. I don't think you got to do all that, because they didn't ask for all of that, unless they left out that step for on purpose. But let's do this. Let's see if we can ping across like Paul mentioned. So basically, we'd have router 1 ping that guy right there to see if he can even reach it, right? So ping 192.168.20.2, and he cannot. So that's basic troubleshooting 101. Let's see if router 2 can ping router 1. And y'all remember, GNS3 be acting funky on me, but I'm not going to resort to this being a bug here. So 192. Let's see if we're going to see if router 2 can ping router 1, which theoretically it probably can't because of the fact that router 1 can't ping router 2. So 20.1, and he can't ping that guy. So here's what we got to do here. We made sure 02 and 03 are in the same VLAN, right? Isn't that what we did? Yes. Are they up? Show interface status. Let's see. I'm pretty sure they're up. Show interface status. Those two are in the VLAN 4010. I'm not sure what you missed. Yeah, I'm not sure. Oh, you said it works for you. Well, what are you using, plant-based brother? Are you using GNS3? So we're definitely missing something here. Or it could be a bug, because that's why I have this love-hate relationship with GNS3. I remember doing a whole stream trying to explain some shit, and then it's like, oh, this was a fucking bug, man. But I don't want to resort to that. Yeah, I know I'll be like, so when shit don't work, I'll be like, man, that was a bug, man. It was a bug. Oh, no, you just didn't know what the hell you was doing. So we definitely have those two in the correct VLANs. What I was thinking that was this needed encapsulation. And then 4010. Bring the network statements up again. All right, let's do that. Let's do this. Show run. We can drill down to just the OSPF statements with the section keyword, right? And just do router, right? What that'll be just all routing protocols. So we got 192.168.20.0 network, 0003 area 0. That seems correct. We did the same thing on this guy. Are you using GNS3? Of course not. Is IP routing set up on the switch? Was I late? Pete, no, we don't have any routing set up on the switch. The lab did not call for it. It did not call for any IP addressing on the switch. The switch is the problem in GNS3. You had this issue in another stream. Yes, you're right. You're right. You are definitely right. We could remove this switch right here, but then it's going to look like the topology we had yesterday, guys. And this switch has been giving me some issues. So let's do this. Just to test our theory, I'm going to use the switch that I know works. This Ethernet switch right here, as opposed to that one right there. Right? Just to make sure. No, I didn't want to do that. I wanted to use this guy right here, right? And use the GNS3 VM. Did he delete? Is he gone? Oh, shit. It went away. Oh, well. Whatever. Farfignugan. Let's do this. 00 to, I guess, Ethernet 0. And then on this guy, it's going to be Ethernet 1 to 00. Right? And if it works, then we know it was the switch. And I need to be careful with this bad boy right here if that's the case, right? So, fair enough. GNS3 gives me trouble too sometimes. Well, plant-based brother, what are you using there, man? Because I forgot what you said you was using. But if it works this time, then we know it's a switch, and I probably just need to get another image or something. I just love this image. It shows the VLANs just how it works on a regular switch. But maybe I need to pull out my hardware and actually use that to demonstrate, and just use GNS3 to show the let's do this. Power this bad boy on. Where is he at? Where is he at? He is powered on, isn't he? Let's go ahead and console into him. That's the Ethernet switch. Console. I guess he's powered on already. Thanks for everything. You're awesome, man. Appreciate that, P-Tasia. Yeah, I tried to see plant-based brothers using EVE-NG, and I need to ride that wave, man, because I do have it, believe it or not. Let's see. I thought I had it on here. I thought I had it on here. Maybe I have it on my other computer, my desktop PC. Oh, maybe I don't. Interesting. Okay, so now that he is powering on, where's the switch, man? Where's the switch? Is that the switch? That's not the switch right there. Oh, there go the neighbor right there. Look at that. Look, we got the neighborship right there. Look at that. Look at that, man. Man, come on, man. That was a switch, man. Y'all see that? Okay, so it really was the bug. Got rid of the switch, plugged it up. They're in the same VLANs for a fact, because that's like we didn't configure any VLANs right here. So by default, they're in VLAN 1, right? Once we did that, boom, it came up. So it's definitely a bug. GNS3, man. GNS3. Those generic switches don't let you console in GNS3. Oh, they don't? Yes, they do. I thought they do. Huh. What was I thinking then? Maybe I was thinking maybe I was thinking something else. Let me see what I was thinking. Oh, I was thinking of the router with the Ether module connected to it. So I was thinking, where is he at? Where is he at? Oh, maybe I removed it. Maybe I removed it. There was another switch in here that has it's basically the router with the Ether switch module connected to it. But y'all see, once I did that, got rid of the other switch, the neighborship came up. We'll even go back to router 1 and check, right? So let's go back to router 1. The router 1 already said, see this message right here lets us know we have a neighbor. So let's read this right here. OSPF 5, there's a levels 0 through 7, right? 0 is the most serious, like, catastrophic emergency event, versus 7 is informational. In between, it's like, you know, you might want to look at this kind of thing. 5 is like informational almost. I'll show you a chart maybe later. But let us know that there's an adjacency change in OSPF. Process ID 1, like we mentioned. And then the number, that's the router ID, 20.2. Who's 20.2? That's this guy right here. Where do we find that information? On FA00, that guy right there. It changed from loading to full. And then loading is done. Remember, we talked about the relationships, right? Or not the relationships, but the states of OSPF. Do I still have them? That's the neighbor states. So before we come to neighbors, it starts out in a down state. Then we attempt to find our neighbor. We go to init state. We go to two-way, xstart, exchange, loading, and full. I'm not going to go over all of them. I'll leave this document. This is a Cisco white paper that y'all can go over at your own times. But before they become neighbors, they go through this state right here before they become neighbors. And they become neighbors when it becomes full, like that, right? So let's go to router 2. And you see that message came across router 2 as well. We could also verify it with show IP OSPF neighbors. Jeez, man, I love that switch too, man. But it's just problematic for me, as y'all can see, man. It is what it is. Without an iOS image, you have to use a router or PC to emulate a switch with iOS. Pretty dumb. Yes. Wait, without an iOS image, you have to use a router or PC to emulate a switch with iOS. Yes, exactly. And what I used to do was have the router with the 16-port Ether switch module connected to it, and I pretty much finagled that as a switch. You know, I pretty much jerry-rigged it. So, and that's a trick that you kind of learn as you kind of play with GNS3 and stuff like that. But anyways, we do show IP OSPF neighbor. That's a command y'all want to know when you want to find out about neighbors, right? So remember that command right there. We see, this is from router 2's perspective, right? Let me bring that bad boy up. So this is from router 2's perspective. We ran show IP OSPF. He said, hey, look, we got a neighbor. It's 20.1. Who's that? That's this guy right here, 20.1, right? Priority. The priority is determined by the highest, let me see what his priority is before I give y'all some false information here. I want to say he's probably going to be priority 1 as well. That's the default priority, neighbor. So priority 1. That's going to determine who is the designated router. Who's the designated router? The designated router is basically the router that is going to keep all of the ways, the database of all the ways to get somewhere. Remember, I always compare network and the roads to highways, right? So the designated router, not necessarily a designated driver, the designated router is the one that he has like a list of all the ways to get somewhere in the network. You want to get to 20.0 network, the 30.0 network, the 40.0 network. He keeps that list, the designated router, right? And that is determined by the person who has I believe, the highest priority or lowest priority. I can't even remember. Kelvin, you in here? Is it the lowest priority or the higher priority? Could you spin up packet tracer to get OSPF broadcast working? We did get OSPF broadcast working. I just needed to get rid of the switch, Jay McLeod. So we could check that it's a broadcast before I veer off. But yeah, show IP OSPF interface FA00. So we got OSPF broadcast. See, that's a network type broadcast. So we did get it working. It's just that switch that I have right there, this switch, that guy, it's just problematic. It's buggy. It just, a lot of things don't work when I'm trying to demonstrate and stuff. So I love that router because it's the iOS module, but I mean iOS, it has the iOS system on it, but it's just buggy, man. It's just buggy. So once I got rid of it, the neighbors came up. So it wasn't any configuring. We wasn't missing anything. It is buggy. That's the thing about using GNS3, man. It's free software, but it's buggy. There ain't no support. You can't call tech support and be like, hey, look, OSPF ain't working. Well, guess what? It's open source software. You just got to learn how to work with it. So what else we wanted to say here? I believe it's the highest priority. Whoever's got the highest priority becomes the designated router. Or I believe whoever turns on first, whatever. That's like a tiebreaker anyway. But the full state, which is what I mentioned, I gave y'all the document, the white paper in the chat right over there. That lets us know that we're in a full relationship with the designated router, right? So from router 2's perspective, guess what? He is the BDR. He's the backup designated router. So he's going to take over when the designated router's down. Remember, the designated router is the guy who has all the routes to get somewhere, right? He keeps that list. If he goes down, then the backup designated router, which will be in this case that guy, he is going to be the one that starts, you know, keeps the list until the designated driver designated router decides to wake up again, right? The dead timer is when we consider our neighbor dead. Remember, 4 times the hello. I'll even run it again and we'll double check, right? So this 38, 37, it keeps going. 35, 34, 33, 32, 31, 30, right? We consider our neighbor dead on the 40th second. But if we receive the hello, because remember, hellos go every 10 seconds, then we start that timer over again. That's why it goes 33. See, watch. 38, 37, 36, 35, 34, 33, 32, 31. We receive the hello, and it starts over again. Right? That make any sense? Maybe we can do a Wireshark capture after this. But we're wrapping up to the hour. I know I always say I want to try to wrap these up in like a half hour, but I like talking about this stuff, and I just usually get to that hour, and that's when I know I've been talking too much. But anyways, we became neighbors that way, right? Remember, he's the designated router, so he's at this point keeping up the list of stuff of the routes to get somewhere, right? That's called the OSPF database, and then he is the backup designated router, as we can see right here, and then that's the dead timer, which I mentioned. We consider our neighbor dead after 4 times the hello. And then the IP address of the neighbor. So he is 20.2, right? I'm 20.2, right? And my neighbor is 20.1. He's my OSPF neighbor. Where did I learn this information from? FA00, which is that port right there. That port right there, right? Pretty good explanations. Man, appreciate that, Pete. So yeah, I guess that's pretty much it. Unless y'all want to, maybe we'll do some Wireshark captures and take a look at the hellos and stuff that's going across. That's pretty much the lab. I gave you guys the white paper if you want to look over the OSPF neighbor states, right? Which was this guy right here. It's in the chat below. There's also a Discord server if you guys want to do some more discussion or whatever, or whoever remembers what the priority, if it's a highest priority or lowest priority, you can hit me up there and give me the answer. Let me see what else. Invite. This is the Discord server right here if you guys want to join and talk some more OSPF. And here are the states, right? We start off as down, attempt, init, and then two-way. We only become two-way if we're not a DR or a BDR. So if we have 5 routers in here, 7 routers in here, 10 routers in here, there's only going to be a DR and a BDR. That's who we become full with. Everybody else are called drothers. That's a deeper subject. Remember I said OSPF? You write a whole damn book on OSPF, but I don't want to get too deep into it. This was just a high-level overview. The next lab will be lab number 49. Let's see what else they wanted to, they said here. We did the extended VLANs and stuff like that. We showed the neighbor come up. It says here, there's a note on broadcast and non-broadcast domains, or on broadcast and non-broadcast multi-access networks. OSPF elects a designated router and a backup designated router for the subnet, which is what I just said. Well, guess what? We only have 2 routers here. He's the designated and he's the backup designated, right? So just like I said, when you are verifying OSPF adjacencies for these network types, make sure that the state is either full DR, which was this guy right here, right? He is full DR. Full BDR, which is this guy right here, router 2. He's full BDR, right? So he's full, and he's the backup designated router, right? Y'all with me so far? Or full drother. I know that's a weird term. Basically, full drother is like full designated, they just say other. So you're not a backup router. You're not a backup designated router. You're not a designated router. You're just somebody else. So, but we only have two routers in this case. So it's kind of like president and vice president. Everybody else is just somebody else in this case. So if that make any sense. Y'all know how I like to just explain things differently. So the output of the show IP OSPF interface command, which we've done already, I'll do it again, shows that the elected DR is router 2. Designated router. So no, in our case, the elected DR was router 1. And I think it's because, remember I fudged up at the beginning of this lab? That's the reason why he became the DR and he became the BDR. So we'll do that again. Show IP OSPF. They said interface FA00, right? And then we can see his state is DR, was a designated router, right? And this is my designated router ID, and that is my interface address. So go ahead and experiment with a little bit. If y'all want to stay after, I'll do a little, maybe some Wireshark captures. We'll take a look at the hellos and stuff like that. But that's pretty much it, man. If y'all like what y'all see, hit me with the subscribe button. I'll do a giveaway pretty soon. Y'all want me with them likes. For now, comment, like, subscribe to the network. Yeah, so next lab, you guys want to stick around after class, right? Lab 49, which is configuring the router ID manually. So you know, remember what we said, the router ID, right? This guy right here? We said that that is determined by the highest loopback address on a router, right? We don't have any loopbacks address, so then if it's like, okay, so we don't have a loopback address, then our router ID is going to be the physical interface with the highest, the physical interface that's up, and it has the highest IP address. Well, in this case, we only have one interface, and that's the only one that was up. So 192.168.20.2. So that became our router ID. Well, you know what? You can manually change it. And that's what we're going to do in the next lab, Lab 49, which is page 212 if you got the book, right? What else we wanted to say? So that's what they're going to have us do in the next lab. We'll do that tomorrow. Let's do some Wireshark captures, all right? What kind of shit is that, right? We over here late night playing with some Wireshark captures. I should go to bed. I got some stuff to do at work tomorrow, but y'all know I love to do this shit, man. So we right click. You can't do it. Oh, I was gonna make fun of plant-based brother over here and say you can't do this on a packet tracer over there. You can't do this on your packet tracer. Start capture, right? And then we can basically, it's kind of like we put in the microscope on this right here, so we can see the packets going back and forth, right? And that's what we're doing with Wireshark. If you want to learn, there's a free course I want to say on Udemy. David Bombal gives you a whole course on Wireshark and show you how to read Wireshark captures, right? So we do start capture and then click OK. It's going to launch up packet tracer. Look, there's even a microscope there. I mean, a magnifying glass, and we're going to see the packets going across the wire there, right? It's going to launch up packet tracer, and we will see some messages going across. What we want to do is we want to filter. Well, there's going to be so much damn messages going across. It's going to be like it's throwing up all these messages at us. We don't want to see all this, man. We want to filter it down to what we need to see. But it doesn't look like there's a lot. We got some CDP messages. We got some OSPF messages. But we want to filter it down to just OSPF messages, right? Let's do that. Let's try it. OSPF like that. And now we're just going to see everything that has just OSPF messages in here, right? So if we erase that, it's going to be just throwing a whole bunch of messages. We have CDP messages, some pings, ICMP, all this other stuff, right? We just want to drill down, maybe DHCP requests, whatever. But we want to see just OSPF messages, right? So after class nerd squad. Yeah, that's what's up, Pete. That's what we're going to call it, the after class nerd squad. Y'all the nerds that be staying after class and stuff for some after stuff. Y'all know I like to wrap this up after about an hour. But then after that, maybe there's some little stuff that we want to, maybe little nuances, little things that we want to pick apart here. And if anybody else want to do some studying on their own, they can do that. But notice here, we put the magnifying glass right there, right? And look, all we see here, this is not really a complex topology. There's not much going on here. We only have a designated router, a backup designated router. Maybe this is what we can do. We can shut it down and then bring it back up, and then we can see some more messages here. But as you can see here, so far, all we got is hello packets. By default, how often do the hello packets go across? Y'all remember? The plant-based brother said, you can't. Oh, yeah. You can. You can use EVNG. That's right. You can do some packet captures on EVNG, can't you? Is it using Wireshark or what is it using? If both routers got rebooted, would router 1 become the DR? That's a very, 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 very good question, Pete. Very good question. I like that. Let's do that and let's experiment with that. Let's save our work before we do that, though, right? So we got router 1. Oh, you know what? This model. Which router is this? I don't want to do that. I don't want to do that with this guy. He's the one with the serial interfaces? Hell nah. If I reboot this router, I don't think they're going to come back up, man. That's the other thing about this model that I have right here. This specific iOS image I have, I guess. I don't know. But all I know is that if I reboot it, I don't think it's going to come back up. I might have to close. Here's what I'll do. I'll relaunch it. But we'll shut down the interfaces first, and then we'll take a look at the wire. So let's do that. So we're going to save our work with write. You could also save it with copy, running configuration, startup configuration, right? 2 ways to save right there, right? Y'all know I like to just spit up all these information to y'all, right? What else we wanted to see here? So we put the magnifying glass right there. We gonna take a look at. Yeah, that's all we got there, man. All we got is hello packets. They often come across every 10 seconds, right? And it's 4 times the hello that we consider our neighbor dead. Well, guess what? it's being sent out of this 224.00.5 address. Wait a minute, we didn't configure anything like that. What is that, right? That's what's called the multicast address. That's an address you might want to remember too. 224.0.0.5. This is the multicast address that OSPF designated routers send those OSPF updates to. So everybody that's in area 0 or area 10, whatever area we made, we're going to send our OSPF updates, our link state updates, our link state requests and stuff like that. We're going to send that out of that multicast address, 225.0.0.5, which is the multicast address for OSPF. Anybody else, all the other routers, are going to make those requests and make those sends on 224.0.0.6. That's another IP address you want to remember too. So 224.5 is the one that the designated router is going to be speaking out of. Those guys are going to be receiving that information from 225.0.0.6. But remember, we don't have any drothers in here. We only have a designated router and a backup designated router. So that's why we don't have the 0.6. Let's take a look at this frame here. Let's pick one. Let's pick frame number, I guess 13. No, let's pick number 6. Break that down and we'll see what we got here. The time it came in. Epoch time. I forgot what that stood for. So epoch time, this is the time and it was captured. Interesting. Right? Frame, that's the frame number, right? Not packets, these are frames now, because this is a local area network. We're not sending it over like a layer 3 or anything like that. Also, that's the other thing I wanted to see too. Let's take a look at the routing table. Show IP routes. See, he didn't learn any OSPF routes because they're connected. They're directly connected. He already know about that route, so we don't have any OSPF routes there. That's another thing too. We should be able to theoretically, remember last time we couldn't ping across? Let's try that too, right? So from router 1, we're gonna ping, we have router 1, ping router 2, right? Let's see if we can do that, right? Ping 192.168.20.2, and now he can ping across. See, that switch was giving me problems, man. That switch, man, it's messing up my damn streams. It is what it is. Everyone sends hello packets out to 225 by the hello interval. Okay, not just DRs. Okay, so you're saying not just the DRs. Oh yeah, BDRs too as well, right? Everyone send hello packets to 225. Okay, DRs just help in database exchange optimization. Okay, good to know too. Epoch time refers to the Unix epoch, which is the number of seconds since 1/1/1970. Really? Shit. Like, that's some fun fact. That's some random ass fun fact there, man. But I didn't know that. Where is that at? Well, we seen it somewhere. Okay. It was up here somewhere. Epoch time right there. This is the time it was captured. Frame.epoch time. So frame time epoch. But where did you get that date from? What is that? Huh? Unix epoch. I might have to look that up, man. You need to let me see that, man. Take a look at that. I know the lecture is already over. We just doing some extra Unix timestamp converter. Interesting. I never heard of this shit. The Unix epoch is the number of seconds that have elapsed since January 1st, 1970. Man, ain't that some shit, man? See, it's little fun facts like that, and having Kelvin around, he like Encyclopedia Brown. No little fun facts like that. I ain't never heard of this right here. The Unix epoch time is the time 0000 on January 1st, 1970. There's a problem with this definition. In that UTC did not exist in its current form until 1972. Yo, that's some crazy shit. I ain't never heard of this right here. Unix time. This is kind of like Y2K from back then or something. That's crazy. Interesting. Anyway, where is the stream there? Okay, so it makes it easy to keep track of time without dealing with silly human things like months and years. Okay, that's good to know. Okay, see, never heard of that. But am I correct in saying that though? They respond in 224.0.0.6. That multicast address. I ain't never heard of it. I mean, I've seen that word epoch time under what is that? It was like the show IPCEF or either like the MAC address. I can't even remember where I seen that before. Not IPCEF. What was that command? There's a command that lets you know what it is. Is it also time zone agnostic? That's another good question too. Yeah, that is true. That's true. Is it? What else we got here? So we got some information on the hello packets. Remember, we say hello every 10 seconds. That is frame number 8. That's the 8th one that came in. That's the size of the frame. What else we got going on here? Coloring rule string. Here's where it came from. No, that's the destination. So source. This is layer 2 stuff right here. Layer 2. I wanted to see layer 3 right there. Here it is, right there. So source. This packet came from 20.2. So this was a packet going from there to there. Right? Destination was 224.0.0.5. Right? The multicast address. That's where the designated router speaks from, right? No, after 2.8, they do unicast. Okay, right. So remember broadcast when you speak to everybody, right? And a unicast is when you finally just know one person you want to talk to. Unicast. So you're talking directly to that one device. So in this case, we would broadcast for any kind of like if we're, let's say if we're a we're not a backup designated. Let's say we're a drawther, right? We broadcast, and then once we find out or get a hold of the DR, then we're doing unicast, right? Is that what you were saying? Actually, yeah, it is. Time zones are managed by local offsets. Okay, good to know as well. The differentiated services field. This is more like QoS, quality of service stuff. Don't think any of this is relevant to OSPF right now. We got the don't fragment. I did a video on this, the flags. If y'all want to go on my channel, deep in my channel for that stuff. The time to live is 1, right? It's like kind of like the one because we're only 1 hop away, so that's why the time to live is 1. What else we got here? OSPF, the protocol type. Source. So it was from here, 20.2, and the multicast address. You would think it would be, the destination would be 20.1, right? Isn't it? Shouldn't it have been the destination? Why is the destination not? Oh, here's the OSPF stuff. This is good stuff right here. Version 2, right? That's for IPv4, right? When it's version 3, it's IPv6, right? This is the hello packet. It's the size of it. That's the source router. Area ID. Backbone. Remember I said that earlier at the beginning of the stream? Here's the information on the hello packet. The network mask is /30. The hello interval. Remember we say hello every 10 seconds. The router priority. Remember we said, so yeah, that's what I meant to ask Kelvin. I couldn't remember if the router priority is it by default is 1. Is it the higher the priority, and that's who becomes the designated router? If that's what you said, or is it the lower the priority is who becomes the designated router at first? Because it goes by the priority first, and if it's a tie, it's whoever has the highest router ID, right? The dead interval is 40 seconds. He is the designated router. He is the backup designated router. Remember what we said about that? Active neighbor. That's pretty much it, man. Let's see what happens when we shut down one of these interfaces, and we'll see what turns down. Higher priority is better. Okay, good to know. And that's a number from 0 to 255. Is that correct? So let's go ahead and shut this down, and then we'll take a look at these Wireshark captures. After that, we'll call it a night. So let's go to router 1. We're going to shut down this interface right here. Remember yesterday we did a debug, right? Today we're just going to actually do a Wireshark capture and take a look at those messages, right? So we're going to go to global config mode. Jesus. Stop using his name in vain. Configure terminal. Well, all I can think of is Derek Jackson at this point, man. This dude be using, man, listen. Let me not even get into that. Interface FA00. We'll shut down that interface, and then we'll take a look at the OSPF neighbor shit, right? Shut that down, boom. And then we see the neighbors down, right? Let's take a look at what messages we got going on here. Boom. Router starting to, yeah, it's a priority. It's an 8-bit value. Though realistically, it depends on who comes up first. Yes, exactly. That's what I was saying too. So high priority is better. Yes, tiebreaker is by router ID. Yes. Correct. And that's pretty much why I think router 1. Well, we turned them on all at the same time. Remember, we pressed that power button, and they all turned on at the same time. But then I think I fudged up the... what happened to our messages, man? Do we got to bring it back up to do all of that? Let me get rid of that filter. We ain't got no more filters. We're still capturing some frames here. Let's see. So we said the dead timer expired, right? They're no longer neighbors now, right? So we just show IP OSPF neighbor. He no longer has an OSPF neighbor, right? Y'all see that? But I wanted to see some stuff come down the pipeline here. Do I need to refresh? Restart the current capture. Continue without saving. Come on, man. You gonna crash on me, man? Let's do this. Let's start it over. Start the capture. Restart that capture. Boom. That interface right there. And then we're gonna bring it back up and then take a look at those packets right there. If Wireshark decides to wake up. Come on, Wireshark. Come on, baby. See, man. CNS3, man. I got a love-hate relationship with this, man. And this is why I want to get my hardware going. Come on, man. Don't do me like that, man. Start a capture over here. Start the capture visualization program. There you go. Let me delete this bad boy right here. Okay, so we got some messages here. We got some hello packets coming already. How the hell? Y'all know where that's coming from? How the hell, if this is shut down, how the hell he's still getting some hello packets? Y'all know why? Because OSPF is still enabled there, and he's saying hello. That's what's going on there. See? Source 20.2. Who's that? That's this guy right here. So he's still saying hello, but he just not getting any hellos back from router 1. So we don't have an adjacency here. Y'all see that? So he's still saying hello till he hear from that old guy down the block. Like, you alive over there, man? So now let's go ahead and bring that interface back up and take a look at what happens, right? I ain't got no filters going on here, so. And y'all notice this is a CDP message, right? Remember we said that in the CDP video? They go across every 60 seconds. See? And there goes that minute of me talking shit, and there go the other 60-second CDP message, right? So we got some CDP, we got some OSPF. Let's go ahead and bring that interface back up. Go to global config mode and no shut that bad boy and take a look at what happens when we look at it across the wire, right? No shut. And then take a look. We got broadcast, we got a reply, and we got all this information here. Remember I said OSPF can be a deep subject, right? We can talk about link state requests, we can talk about link state updates, we can talk about acknowledgments and all of that stuff, right? But all of this stuff is OSPF messages right here, right? In short, they basically, like, they becoming neighbors, right? And he's like, oh, you an OSPF neighbor? Yeah, I speak OSPF too. And he's like, you got a destination to this network? Yeah, I got that. And then he's like, you know, piecing together a map of the network with all the, yeah, you got the network to a destination to network, blah, blah, blah. Yeah, I got that too. And then they start exchanging information, and then finally they become full message. So I'm not going to like break all this stuff down to, y'all can do that if y'all want to with GNS3, but that's what happens there. And then finally they become neighbors. And I want to see where is the message that lets us know that we finally become neighbors. We got these updates and acknowledgments. When they finally get a good picture of the network, then they become neighbors. And as you can see, it went from loading to full. Remember what we talked about that was, right? Loading is, boop, loading. In this state, the actual exchange of link state information occurs. And that's what was going on right here, right? All this LS means link state, right? Based on the information provided by the DBDs, database descriptors, routers send link state request packets. Where's the requests? We got a request in here. There he is right there. We got a link state request. The neighbor then provides the requested link state information in link state update packets. We got an update. There it is right there. There go another update. There go another update. So they keep exchanging information until we get a good picture of the network, of how it looks like. That's how OSPF works, right? During the adjacency, if a router receives an outdated or missing LSA, and just like piecing together a puzzle, it requests that LSA by sending link state request packet. All link state update packets are acknowledged. Well, guess what? Where's the acknowledged? Right there. That's acknowledged. So that's the difference between these bad boys, right? We got a database descriptor. We got some requests. We got some updates, requests. And he's like, hey, look, man, I'm missing a way to get to the 50.0 network or whatever. We only got 2 routers here, but I'm just giving you an example. And you'd be like, I'm missing a way to get to the 74.0 network. You got some ways to get there? And then the other router's like, bro, I got you, man. This is how you take it. This is how you get there. And that's exactly what's going on here, where they're exchanging all those LSAs and LSUs and all that, right? And then finally, what we said full. So remember, we said we went from loading to full, right? And what was full? In this state, routers are fully adjacent with each other. All router and network LSAs are exchanged, and routers' databases are fully synchronized. Full is the normal state for an OSPF router. If a router is stuck in another state, it is an indication that there are problems with forming adjacencies, which in our case was the fucking switch. Excuse my language. We had to remove it. In case y'all are just coming in late, this is just the after class thing. We wrap this up in about an hour. You may want to replay this. We started at 8 p.m. Eastern Standard Time, Monday through Thursday, right? And usually about the hour, I usually wrap it up, right? And then after that, we just do a little bit of bonus stuff, after class stuff, right? We finished at 9 o'clock. We're about 23 minutes deep into it afterwards, right? So the only exception to this is the two-way state, which is normal in a broadcast network, right? We said that this was the broadcast network right here, right? How do we verify that? We did the show IP OSPF interface, right? Command, right? So we did like this right here, show IP OSPF, and then interface. We only got one interface that's participating in the OSPF in this case. That was FA00, right? And we'll see the network broadcast, network type is broadcast, right? What else they said? Routers achieve the full state with the DR and the BDR in NM or NBMA broadcast media, and full state with every neighbor in the remaining media, such as point-to-point and point-to-multi-point network. If you want to know what point is, look at yesterday's screen. That's what we did OSPF in a point-to-point network. This is not a point-to-point network. Oops. This is a broadcast network, right? So the DR and BDR, right, the designated router and the backup designated router that achieve full state with every other router on the segment will display full drawther when you show the show IP OSPF neighbor command. Let's go ahead and do that real quick, right? So let's do show IP OSPF neighbor, right? He's full DR. So wait a minute, does that mean he is the DR and then the other guys? Hey Kelvin, real quick, this DR, does that let me know that I'm the designated router, or is he the designated router? Because this is neighbor ID, right? So from router 1's vantage point, my neighbor ID is 20.2, right? But this state right here, is that my state? Or is that the router? Is that my neighbor's state? We already determined what the priority is, right? Highest priority is who becomes the designated router. I think in my case, it would be me. Bro, sorry, man. I couldn't join your stream these days. Hey, it's all good, Brian. Did you ever get that job, man? Yeah. Oh, my interview went good, though. Confirmation email has yet to come for next round. That's what's up, Brian. That's what's up, man. Good luck with that, man. I remember you said you had a job interview and you just disappeared after that. I'm like, he must have got that job. But, appreciate you for tuning in and stuff like that. Oh, so this is the neighbor's state is what you're saying. So my neighbor is the designated router. You're telling me router 2 is the designated router? Yes, probably, because he has the highest router ID, 20.2, whereas I'm 20.1. So yes, glad you pointed that out, man. And we said what the dead timer is, right? The address of the physical address of that router. Because remember, we can change the router ID. We can change the router ID, but that is the physical address of that interface that's there. And then the interface is FA00. So that right there. What else they said? Command. So we issued that command on either DR or BDR. This simply means that the neighbor is not a DR or BDR. That's what drawther means. Remember, DR other. That's what or you can say drawther, whatever, right? So if you're not a DR or BDR, then you're going to be a drawther. That make any sense? Anybody got any questions or anything like that? I know it's like after class. We about to wrap this up. But since the router on which the command was entered is either a DR or BDR, this shows the neighbor as full router. So yeah, I guess in that case, when you do show IP OSPF neighbor, this is the information about the neighbor. So in this case, he is the DR and router 1's the backup designated router. And I think we can tell that by the router ID. So that's how we can tell. Tomorrow's lab is lab 49, page 212. Configure router OSPF, configure OSPF router ID manually. So remember we said the router ID is something that is determined by the whoever has the highest loopback or priority, and then the highest physical interface address. So I'm sorry, highest loopback and then highest physical interface address. That's up. So that's pretty much it, man. If y'all like what y'all see, man, make sure y'all subscribe, man. Run me those likes, and appreciate y'all for tuning in. I'll do a giveaway pretty soon too. So for now, comment, like, subscribe to the network. Bruh.